Hello and welcome to another exam paper walkthrough. Today we're going to be looking at the GCSE Mathematics Edexcel papers, and we're looking at a real modern set. This is set 22. This is their most recent set, and I'm going to be doing paper 1H, so that's the higher non-calculator paper. I'm going to do this session in chunks of 10 questions, so I'll do 10 questions and then stop the video and start another one. I'll name the videos according to which questions are done within them. That just keeps my file sizes down, and it also means you're able to navigate them a bit easier. Attached to the video should be a blank copy of this paper. It's strongly recommended that you've either done the paper beforehand or you pause and play and do the paper and then check it each time. I'm going to do them a page at a time, so I'll do a page and then I'll have a quick look at the mark scheme and just check that I've not made any silly mistakes. You can see here from the footer, this is spring 23, and today's date is spring 23 pretty much. This is the most recent copy, most recent practice paper that Edexcel have released. I've not done the paper before, so we'll see whether there's anything that catches me out, and we'll make a start. So question one. So we've got 25 questions, right? Okay. Here is a biased spinner, so unfair spinner. When the spinner is spun once, the probability that it lands on red or on yellow or on green are given in the table. Work out the probability that the spinner lands on red or on yellow. So red or on yellow, we need to add the probabilities together. So we're doing 0.25 plus 0.2, so that's going to be 0.45. So question B, Yang is going to spin the spinner 300 times. Work out an estimate for the number of times it will land on purple. So in effect, all we're doing is 300 multiplied by 0.2. That's going to be, I can change that to 30 times by 2. Using my knowledge of place values, in effect, what I've done is divided this by 10 and times this by 10, so the answer won't change in size. So we're looking at 60. Wow. Seems then it's going to spin the spinner 300 times. Work out an estimate for the number of times the spinner will land on purple. We're told that the purple there is 0.2. Okay, no drama. I'm just started to look at the mark scheme and I've got a different answer here. There's a misprint in the question. Not to worry though. So I will, and this really doesn't affect anything. What the question actually has done by the mark scheme is work out an estimate for the number of times it will land on green. So I'll do that as well. If there's a misprint in your actual exam, it's very unlikely because it's normally gone through a couple of rounds of checking. But if I was doing that, I'll kind of do this separately. So the probability of it being green, so P probability of it being green is going to be equal to 1 minus the other 3 probabilities added together, which is 0.246, 0.65. So we're looking at 0.35. So the number of times we would expect it to be green would be 300 times by 0.35. And again, I'm going to use similar to what I did over here, using my knowledge of place values. I'm going to divide by 100 times by 100. So that's going to be the same as 3 times by 35, which is going to be 105. So what the question actually asked by the mark scheme was that one, but no drama there. We will go to the mark scheme. I thought that what made me question that was that seemed a lot for 3 marks. So that's why I had a quick scan at the mark scheme. So if we look at the mark scheme, I'll have to kind of make them up for the part B, but we'll find out. So this is a B1 mark. Right. So I am going for a B1 mark here. And for here, I'm going to do it via the green first of all, because that's what they've got the actual marks awarded for. M1 allowing use of their 0.45 from part A. Oh, okay. for a complete method. So arguably we've got M1, and then A1. No, sorry, we've got M1 for a method, and then A1 for 105. If I was making this up, I'd struggle to give it 3 marks. I'm going to go for M1, and then however you've done the method. I probably have to go for a processing mark, a method mark, and then an answer mark. If I was trying to award 3 marks, which I think is only fair to do, but that's quite generous. Okay, question 2, expand 3c cubed multiplied by c plus 4. So I'm doing 3c cubed times by c is going to give me 3c to the power 4, and then 3c to the power 3 times by 4 is going to be equal to 12c cubed. And straight on to question 3. I'm seeing these more and more often. It might be a hint for the summer. So we're adding a fraction, adding 2 mixed fractions, but we're told what the solution is. The way you would do this, you would always start with the left-hand side and then follow it through and hope that show that it equals the right-hand side. So you've got 2 pretty common methods for this. I will go over the more standard but slightly longer method first of all, then I'll go over the slightly quicker method. So the first one is I'm going to convert these to both bring improper fractions. So I'm going to do that by multiplying the whole number by the denominator and adding the numerator. So 2 times by 3 is 6, plus 2 is 8. So I'm looking at 8 over 3, plus 3 times by 4 is 12, plus 3 is 15 over 4. I then need to put these to be in both fractions over the same denominator. So I'm looking for the lowest common multiple of 3 and 4, which is going to be 12. To do that, I need to times the first fraction by 4, which will give me 32. And I need to times the second fraction by 3, which will give me 45. Now that we've got them over the same denominators, I can just add the numerators. So that's going to become 77 over 12. And then 12 goes into 77 fully 6 times, which would be 72. Sorry, 72. So it goes in fully 6 times with 5 left over, which is still divided by 12, which was what we were asked to show. So we can stop there. So the second method that I tend to use a bit more often, the maths behind it is slightly more complicated, but the theory behind it is slightly more complicated, but the math is much more straightforward. So what I'm going to do is I'm actually going to split these into number parts and fraction parts. So I'm going to treat it as 2 plus 3. And my fraction part is 2 over 3 plus 3 over 4. And then 2 plus 3 is obviously 5, is my number part for now. And then my fraction part becomes, I need to put them both over the same denominator, which would be 12s, times the first fraction by 4, so that would become 8, and the second fraction by 3, and so that would become 9. And then when I add those, that's going to become 5 plus 17 over 12, which is the same as 1 and 7 over 12. Which gives us a total of 6 and 7/12. Put a few equal signs in just to make my working a little clearer. And there's the 2 methods. Okay, second method, all it does really is it reduces, it means that we don't need to do, the more complicated multiplication of 8 times by 44 and then 15 times by 3, and then how many times does 12 going to 77? It saves on that those questions slightly. Have we got any more questions on that page? Let's have a quick look. That's it. So I'll have a quick look at the mark scheme and award the marks. So for question 2, we've got B2 for the correct answer only. So B2, I'm awarding there. But you could have a B1 for either part being correct. So if you've got 3c to the power 4 plus, and then you've made a mistake on the second part, you can pick up 1 mark. Or if you've made a mistake on the first part but got the second term correct, 1 mark. Okay, and then the second question. And it does show both methods, which is nice. We'll go for this one. Okay, so the first one is awarding a method mark for converting into improper fractions, or for, okay, interesting. And if you've used the second method, you would pick up the method mark here. And then the second method mark is either for this method of putting them over the same denominator, or repeating the mark scheme, which is okay. We'll go M1 there. And then final mark is for the correct answer, or for working it through to the answer. Okay, and question 4, solve the simultaneous equations, and we've got 3x minus 5y and 4x plus 3y. So if I call this equation 1 and this equation 2, and it's completely up to me if I'm at my x coefficients the same value or my y coefficients the same numerical value, one being negative, one being positive isn't an issue. If I make my x's, I'm going to go 12s. If I make my y's, I'm going to go 15s. There's not really anything much in it. I'm going to make my y's the same coefficient though. So I'm going to times the equation. I'll do it over here. I'm going to take equation 1 and I'm going to times that by 3. So that will give me 9x minus 15y is equal to 75. And I'm going to take equation 2 and I'm going to times that by 5. So this working isn't necessary. So kind of what I'm scripting here isn't necessary, but it makes it clear to your marker exactly what you've done. So I would strongly recommend it. So I'm looking at 20x plus 15y is going to be equal to 70. And now that I've got my y coefficients the same values, but one negative and one positive, what I'm going to do is I'm going to add them together. So I'm going to say my next line of working is going to be equation 3 plus equation 4. And that will give me 29x is equal to 145. From there, I'm going to divide both sides by 29. So divide both sides by 29, and that gives me x is going to be equal to 5. So from there, I'm going to substitute my value of x into one of my initial equations, and I'm going to go for equation 2 to avoid the negatives. So that means that 4 lots of x would become 20 plus 3y is going to be equal to 14. So minus 20 from both sides, y would be equal to minus 6. So y is going to be equal to minus 2. And then it's not necessary, but it's 4 marks. So I'm going to do a quick check with equation 1, because that's the one that I didn't use in the beginning in this substitutions phase. So 3 lots of x is 15, and then minus 5 lots of minus 2, so that would actually be plus 10, and that is equal to 25, so I know I've got that right. So I'm looking at x being 5 and y being minus 2. And that's the only question on the page, so I'll go straight to the mark scheme at this point. I'm going to bring in a blue pen just because I missed the colour. There we go. Okay, so where am I? M1 for correct method to eliminate x's or y's. So it's a M1 for eliminating the x's or the y's, and then an A1 for the value for x. M1 for substituting the variable to find an M1 for substitution to find the second variable, so M1, and then an A1 for my 4 marks. Well, technically I could have put my 2 A marks down there, but that's absolutely fine. Okay then, question 5, factorize. So we'll stick with blue. So to factorize, I'm looking to put it into 2 brackets. To make the x squared coefficient, both brackets are going to start with x's. And then I'm looking for 2 numbers that multiply together to make the back number and that add together to make the middle number. So my only options here are going to be 8 and 1. No, it's not. It's going to be 9 and 1. And I'm going +9 and -1. There we go. So my brackets are going to be +9 and -1. So we'll put it on the answer line, x + 9 and x -1. Hence solve. So if we're saying that that's equal to 0, what that means is that one of the brackets must be equal to 0, because for two things to multiply together to make 0, one of them must be equal to 0. So either to make this bracket 0, x would need to be equal to -9, and to make the second bracket 0, x would need to be equal to 1. Okay, right. And interestingly, we've got another mistake in the question on the paper. So it's saying that this is worth 5 marks, but they've only allocated 3 marks. So let's have a look at that. And we'll change that to 3. I'll check the marks at the end of the paper just to see whether they add up correctly. And we'll move on to question 6. Simplify a to the power 0 where a is greater than 0. So anything to the power 0 will always be equal to 1. So there we go. Okay, and we'll go to the mark scheme then. So for factorizing, where are we? Sorry, question 5. Okay, so we've got whichever method we've used to factorize, and then A1. Technically speaking, if you got these the other way around, you would still pick up 1 method mark. Or if the 2 numbers that you had here, so I'll actually bring the mark scheme in just to explain it in a bit more detail. If I can find it. Just because it's worth discussing very briefly. What the mark scheme says is it's M1 for ±9 and ±1, or for where you've factorized it, but the 2 numbers multiply together to make -9, or they add together to make 8. So that's kind of going back to this this bit here where I said that I needed 2 numbers that multiply together to make -9 and added together to make 8. If I made a mistake somewhere, but one of the pairs was correct, either the 2 numbers multiplied together to make -9 or added together to make 8, I could still pick up that method mark even if I didn't get the numbers 9 and 1. Okay. Right. For the hence solve part, we're looking at it just says B1 for -1, -9 and 1, so B1. So that's 3 marks awarded there. And then for this one, it is just a B1. Okay. Right, on to question 7. So the line L is drawn on the grid, and we've got the line. Find an equation for L given your answer in the form y is equal to mx plus c. Okay, so I'm going to work out the gradient first of all. So m is the gradient, and let's just pick two nice points. So checking it on the scale, so this is 3 up and 2 across, positive gradient of 3/2. And then the intercept on the y-axis is c. C is going to be equal to -1. So the equation of the line is going to be y is equal to 3/2x minus 1. And obviously, could have other versions of 3/2. We could have had 1.5, or we could have had 1.5. That would be fine as well. And that's it for that page. So the mark scheme says a method for the correct method to find the gradient or the correct value of c. So straight away, I'm going to award it for the first one of the two. So that was my first one. And then an M1 for the use of y is equal to mx plus c with either m or c correct. And actually, let me just see if I can move that back down. Don't let me. But we did have a -1 before I moved the page. Right, so we will award M1 for in the correct form and then A1. Okay, and then we'll move on to question 8. So question 8 says expand, and we've got a triple bracket to expand. Interesting part there, we've got, you can expand this in any order that it appears. Let me just, before I waffle too much, 3 marks. Normally an expanding is worth a bit more than that. The reason that this may be worth less is because what we've actually got is a difference of 2 squares between this bracket and this bracket. So what I'm going to do is I'm going to save the x plus 2, which is in effect the easier one, and it's also the one that's not completely the square, to do second. And if I expand this first bracket, you could do it if you haven't spotted this difference of 2 squares. You could do it however you particularly wanted to, but difference of 2 squares is going to be the first term squared, so 9x squared, and then minus the second term squared, so -1. And then we'd expand that kind of like how we would a normal double bracket. So that's going to give me, so x times by 9x is going to give me 9x cubed. X times by -1 is going to give me -x. 2 times by 9x is going to give me plus 18x squared. And then 2 times by -1 is going to give me -2. So when I put this in size order, sort of descending from the highest power of x, I'm going to go 9x cubed plus 18x squared minus x, then -2. And I'll put that on the answer line just because that makes it easiest for your examiner to be able to spot. Right, and 3 marks available for that. However, we've got a couple more questions on the page, so I'll come back to that in a second. Factorize fully. I'll do this in stages. The highest number I can take out that is a factor of 10 and 15 is 5, so I can take a 5 out. I also have a c common to both parts, and I also have a d squared common to both parts. And then I would need to times 5 by 2 to get 10. I need to times c by c squared to get c cubed. My screen point is slightly off. And then I need to times d by 1 to get d squared. I don't tend to put another d in though. Sorry, I don't tend to write 1 in though. 5 times by 3 would give me 15. C doesn't need to be c times by 1 would give me c, and then d squared times by d squared would give me d to the power of 4. Okay, and then question 10, simplify fully. In terms of my numbers, what I'm going to say is 3 goes into both of those. It goes twice into that, once into that. I can cancel that and that. off each other, and I can cancel that with that. So that's going to give me y squared over 2x. There are other ways we could write that slightly differently, but I would go for that. Okay, and that's the last question on the page, and that's also question 10. So we'll mark the page and then we will stop briefly. Okay, for question 8 then, let me find it. Okay, so okay, they haven't spotted in the mark scheme that it's a difference of 2 squares, I don't think. Interesting. M1 for correct. Okay. M1 for correct intention of multiplying out all 3 factors by multiplying 2 factors allow for 1 error. So we would go for that line would be an M1. M1 for expanding by the 3rd bracket, M1, and then an A1. Okay, and then A1. Right, question 9. Factorize fully 10. Okay, so we're just going straight B2. But it says B1 for correct partial factorization, e.g., so if you've not spotted that 5cd squared was the full factor that we could take out, if you've only spotted part of that, then you can pick up 1 method mark, 1 B mark. And question 10, we're looking at B2 for the fully simplified version, but you can also have you could also have 0.5 y squared x to the power minus 1, and there's a few other versions that are fine. Okay, so I'll stop the recording there. I'll give it a few minutes and then I'll start another one up, but that's the first 10 questions.